Thank you. It's a privilege to be with you all today. We're going to talk about different cosmologies, and one might ask, why bother? We could take the Buddhist approach and say, I don't need to know all how I got into this mess, just tell me how to get out of it. But there's some advantage to knowing how you got into it. For example, I'll tell a little joke. There was this lady who was having a terrible time finding anything she wanted in the department store. It was getting very close to closing time, and the clerks were getting very anxious about getting closed and wanted everybody to leave. But in frustration, she finally asked one of them, "Sir, could you help me out?" And he says, "Certainly, madam. Which way did you come in?" So there's an advantage to trying to understand how we got into the situation we find ourselves. Now, last night, as Swamiji pointed out, all knowledge is within us, even the secular knowledge, but some of it's not of much use. We want to get the kind of knowledge that's useful to us. But there's another way to look at things. We each get attracted to certain kinds of ideas and activities and certain bodies of knowledge. And so somehow we have to give that a twist so those things that we are naturally attracted to will still enrich our spiritual life. Now, some of you did some Tai Chi earlier. That's actually kind of a martial arts approach, If you have martial arts has to do with trying to use the energy of your opponent to your advantage. So we take the things in the world that might be seen as obstacles to spiritual life and give it a twist and make that energy work for us and help us in our spiritual practice. So we're going to be looking at several aspects today, and so if one session doesn't appeal to you, hopefully the next one will, because we're going to be doing all sorts of different things. This morning session will be fairly scientifically oriented, so if you have any kind of science background, then this might appeal to you. The late afternoon session will be more musically oriented and artistically oriented, so that might appeal to others. And then the middle session will have to do with the ideas of consciousness, which hopefully we all are. And so if you have a more psychological interest, and then that session might be more interesting. But I will try to make it understandable. Each one will be understandable to everyone, no matter what your background is. Well, models are very important for us to try to understand the world. And Sri Ramakrishna himself would frequently use models to try to describe things. For example, he used the analogy of the bell fruit. He said a man wanted to know the weight of the fruit. He separated the shell, the flesh, and the seeds. But can a man get the weight by weighing only the flesh? He must weigh the flesh, the shell, and the seeds together. At first it appears that the real thing in the fruit is the flesh, and not the seeds or the shell. Then by reasoning you find that the shell, the seeds, and the flesh all belong to the fruits. So you see these kinds of simple analogies are really a model that Sri Ramakrishna is using to explain things. And we each use things that are common to our experience or to the experience of our listeners as ways of describing something that is beyond our ordinary experience. And in this case, this is the type of spiritual realization that was natural to Sri Ramakrishna, but not so natural to most of the rest of us. And so he was trying to explain these concepts to us in a way that we could understand. In another example, he uses the cow. He says, however great and infinite God may be, his essence can and does manifest itself through man by his mere will. God's incarnation as a man cannot be explained by analogy, but one must feel it for oneself and realize it by direct perception. But now he's going to go ahead and give you an analogy anyway. An analogy can only give us a little glimpse. By touching the horns, legs, or tails of a cow, we in fact touch the cow herself. But for the essential thing about the cow is her milk, which comes through the udder. The divine incarnation is like the udder. God incarnates himself as man from time to time in order to teach people devotion and divine love. Now, science and religion have had sort of a rocky road together through the history of mankind, sometimes being useful and sometimes not so useful. One of the early things that people thought about the heavens and a way to try to figure out something about the heavens was to look at everything as circles. Now, the reason they did that is that they felt that circles were the most perfect form. And since circles were the most perfect form without any angles and without any distortions of shape, that means everything that's heavenly must be circular. And so they tried to fit the orbits of the stars and the planets and the moon and the sun all into circular orbits. And as their measurements got better, they found that things didn't quite fit very well, and pretty soon they had to invent circles upon circles upon circles to try to fit the evidence to their model. Well, eventually they had to give up that model and come up with a different model. So sometimes models get in our way. We get stuck in a model, and then we try to shove everything into it. Sort of like Cinderella's stepsisters who would cut the heel off or their toes off to try to fit into the shoe. We take a model and we have all this data and evidence that we see in the world, and we kind of shove some of it under the carpet, and we figure, well, we've probably got this wrong, and we'll measure it again later, and we'll invent some new parts that we don't know about that'll make the model work. And so eventually the models get messy, and I think that's what we'll talk about, the Big Bang model a little later. I think this is what's happening with the Big Bang model in our cosmology, is that it's not working terribly well, but people are so wedded to it, they jam all the evidence to make it fit. So, now let's see, what do we do here? Do we just push it down button? It's not pushing. Is it, where is it?
No, well.
Not responding.
Down now.
So we can just go down page or something. Oh, no, that's not responding either.
This also is like that model.
Stubborn. So, now it's going to work. Thanks, good. Then, of course, later, Newton came up with his laws of motion, and through his laws of motion, he could demonstrate that things in the world worked very systematically, and that all motions followed these laws, and so that if you could figure out where everything was in the universe and where it was going, you should be able to predict the entire history of the universe, backwards and forwards. So this became like a giant clockwork, and so God then created the universe with all these rules that Newton has now discovered. And then all God has to do is sit back and watch. So that was another model that we had of the universe. And then in the early part of this century, we noticed through our astronomical observation that the universe seems to be expanding, that no matter where we look in the universe, things seem to be going away from us. And so the assumption is, well, if it's all going away from us now, it must have all started in one place at some time in the past, and perhaps through some big explosion or a big bang, it got this momentum to suddenly disperse in all directions. So that's really kind of the origin of our current Big Bang model, our cosmological model. That somehow 13 to 15 billion years ago, there was this enormous Big Bang, and everything in the universe was started from a singularity and expanded into the universe that we now have. All right, so before we go on with the slides, let's go on with a few other matters about the difficulties with some of our scientific models and where the science was at, say, the beginning of the last century, at about 1900. We had the equations of gravity, we had Newton's laws of motions, and there was a theory of electromagnetism. And in these theories, they took gravity, electricity, and inertia for granted. Those were just givens. They were there in the universe. There wasn't any explanation of them. They were just there. And there were these laws of conservation. Energy in the universe was conserved, momentum was conserved, angular momentum was conserved, and matter was conserved. But there were some problems in the physics. There was a great deal of optimism that they would be able to iron all these little wrinkles out, but there were some rather annoying problems. One of them was the nature of light. Some of the experiments showed that light was a particle, and other experiments showed that light was a wave. Now, if it was a wave, what was it waving in? We're familiar with like water waves or air waves. My sound is going to you by compression waves in the air. What was it that light was waving in? And if it was waving in something, what was that medium stationary with respect to? Or was it moving with respect to, say, the Earth, which is kind of our normal frame of reference? And so they postulated that, yes, indeed, there must be some medium, and they'll call it the luminiferous ether. And so they went about trying to detect, was the Earth moving through the luminiferous ether, or was it stationary with respect to the sun, or with respect to something else? Or could we measure the motion of this ether with respect to anything? And what was the speed of light? And did that change depending on what your speed was through this luminiferous ether? Can't say that word. For example, if you're on a train and you throw a ball to the person at the other end of the car, the speed of the ball, as looked at by you on the cab, will have a certain velocity, but as looked at by somebody on the ground, it will have the speed of the train added to it or subtracted to it, depending on which way you're throwing the ball. So this was what they were looking for with light. But it turned out that the speed of light was the same no matter what they measured it with respect to, so that there didn't seem to be any difference whether the Earth was traveling in this way in its orbit around the sun or whether it was going this way in its orbit around the sun. Didn't make any difference. And they also started trying to figure out what this ether could be like, and it seemed to have the strength of many times your best steel, and yet be completely able to have everything move through it. So that didn't make a lot of sense either. So they finally had to throw away this ether concept and realize that for some reason light wasn't waving in anything, and it had the same speed no matter where you were. So this was a great problem. There were some other problems. One was that bodies, when they got hot, would tend to radiate with certain frequencies of radiation, but it wasn't the way that the current models predicted. The current models predicted that there should be a continuous emission of radiation, and it should get higher and higher amounts of radiation in the ultraviolet and beyond. This was called the ultraviolet catastrophe because their models weren't working. In common sense language, you could say that the question was, why can't you get a tan sitting in front of your fireplace? The fire in your fireplace doesn't create ultraviolet radiation to any degree, and so you don't worry about getting a tan. You might get burned just from the heat, but you're not going to get a suntan. So this was the problem, not enough ultraviolet radiation. And the models didn't work. The other problem was that our typical model of the atom was that it was made up of electrons and protons, and the protons were all sitting in the middle real tightly in a tiny little space, and the electrons were sort of roaming around outside. And so, since we already knew about gravity, and Galileo had shown us how the planets go around the sun, according to various laws of motion, we figured, oh, well, so the electron is sort of going around the proton because it's attracted to it not by gravity but by electrostatic attractions. Negative charges attract positive charges. So it's going around like that. Well, the difficulty is that, again, from the laws of electromagnetism, the electron should continuously lose energy and fall into the proton. And the two would just sit on top of each other, and there wouldn't be any way to keep them apart. So that model didn't work very well either, since it was obvious that the electrons were not sitting on the protons. They were continuing to stay around the proton in a rather tight area. So these models simply weren't working very well. And so they had to try to come up with some new models. Now, Einstein was one of the key people that tackled some of these things. Another problem was the nature of light, as we mentioned. Some experiments showed it was a wave, some experiments showed it was a particle. Which was it? And as we said, there's the problem of the ether and what was it waving in and so forth. All right, so we've done this. Now, space and time. Space and time were thought of as absolutes. There was space and there was time. These were like the platforms in which everything happened, and all of our rules of physics were described in terms of this absolute platform of space and time. But what Einstein discovered in his thought experiments and eventually his mathematical formulations was that if we throw out that assumption and take a new model that space and time are somehow intertwined and relative to the observer, that we can fix some of these problems in our physics. Some of these anomalies will go away. And so this bothered him, actually. He got rid of some of the problems, but then he got bothered by, well, there's got to be something objective in the universe. This is a real universe, after all. It's got to be a real universe. And so what is objective? What can all the observers agree upon? And he came up with this equation of separation, which is up at the top there, which is kind of like the Pythagorean theorem, if you can remember from your high school years or your middle school years, where you had a triangle and you had the three sides of a right triangle, and the square of this leg plus the square of that leg equals the square of the hypotenuse. And so if you wanted the length of the hypotenuse, you'd take the square root of the sum of those two. Well, in this equation, you have not the sum, but the difference between the distance separation of two events and the time separation in two events. Now, because of that minus sign, it led some mathematicians to speculate that time is somehow imaginary space. And so there's a little imaginary unit in there, and when you square it, you get the minus sign. That might be useful, might be not. But the interesting thing here is that this is what Einstein found was the objective separation in the combination of space-time that all observers could agree upon. But there's a very interesting consequence to this equation. It says that two events that are separated by a light beam have zero, or what he called light-like separation. Now, to me, this is a very interesting consequence. What it means is that this objective separation between me and my seeing you is zero. My separation between me and seeing the moon is zero. The separation between me and seeing Jupiter is zero. When you look at Jupiter, you see it about 40 minutes ago, but you see it 40 light minutes away. So the distance away is 40 light minutes, and the distance ago is 40 minutes, and you put those two numbers in there and square them, and you get nothing. You get zero. So the objective separation is zero. So this is a very interesting world that we live in, that it seems that we have projected this universe out there in space by seeing it backward in time. And in some peculiar sense, space and time are a pair of opposites that compensate for each other in this illusory world of ours.
What does it mean, separated by light beam, events separated by light beam?
Yes, well, when I see Jupiter, that means there were photons or light bouncing off Jupiter and then reaching my eyeball. So the event of the photon leaving Jupiter, the event of the photon reaching my eye, those are the two events, and those two events are separated in space and time by zero separation. They're separated in space and they're separated in time, but those numbers are equal, and when you put them in this equation, the total separation comes out zero. Now, another interesting thing Einstein came up with was that matter was equal to mc squared. And it is very possible that this equation came about as a suggestion of Swami Vivekananda to Nikola Tesla. We know that Nikola Tesla went to Swamiji's talks in New York, and they talked about these things at Sarah Bernhardt's party. And he asked Tesla if he could demonstrate that matter was simply some sort of potential energy. And Tesla thought he could do it. Well, it turns out, we found out from some relatives of Tesla that live in Tasmania, that Tesla was actually a good friend of Mileva Einstein, who was Einstein's first wife. And if you're lucky enough to see a very early edition of these papers, her name is on it. And after they divorced, her name was taken off. But she was actually a co-author of the paper that has this E equals mc squared in it. And it's in the appendix. And it's very possible that Nikola Tesla and Mileva discussed these things, and then when Mileva saw what Albert was doing, she could see that he already had an equation that had an expression for the energy compared to the wavelength of the light, and then he also had something for connecting the mass to the wavelength, and all he had to do was put them together, and you get E equals mc squared. So it's very possible that Swami Vivekananda had something to do with this equation. Can't prove it, but it's very possible. So this is another interesting equation that shows that our universe is much more uniform than we might think. That we tend to think of it in terms of matter and energy. But apparently matter and energy are really, in some sense, equivalent. Now, the way this equation is often described in textbooks has to do with nuclear bombs, unfortunately. And it doesn't really express the essence of the equation accurately. The way people often will sort of glibly talk about this is that, oh, now we know that energy can be converted into matter and matter can be converted into energy. That's not what the equation says. The equation says the energy is equal to the matter times c squared, and they are equivalent. Now, the reason we tend to think the other way is that when you have something like a nuclear explosion, what's happening is the mass of the hydrogen is greater than the mass of the helium that you're creating. And so it appears that that mass has disappeared and become energy. But what people fail to realize is that energy is simply in transit to somewhere else. If you heat something up, it has more energy and it's more massive. If you separate something from the Earth so that it has more potential energy to fall, it is actually more massive. Now, that's another one that's confusing because we tend to think that the gravitational pull gets less as you get further away, which is true, but the danger of falling gets greater. You can get more energy the further away it is by letting it fall down. I can't get much energy out of letting this pen fall from here, but if I hang it from the ceiling and let it fall, I'm going to get a lot more energy out of it. And so these effects are so minuscule that we don't have anything accurate enough to weigh them. You're not going to weigh the difference on a scale of these things. But theoretically, what's happened is that the energy has simply been transferred from one thing to another. It hasn't been, you haven't destroyed the mass and created energy. You've simply moved the energy that used to be in the hydrogen, and now when you change that to helium, that has less mass, and everything else that's gotten heated up and blown up and moved around now is slightly more massive. But that's over about 15 cubic miles, and you're not going to measure it. You're not going to see a mass difference in any particular object. So that's an important point. All right, now, the other great revolution in our physics in the last century was quantum mechanics. And this helped to solve this difficulty with the old planetary model of the atom. And key to the quantum mechanics is this idea of Heisenberg's uncertainty principle. Let's see if I've got that next. Well, let's go through this. The question was, why doesn't the electron sit down in the proton? And why do hot objects not radiate with a full set of frequencies? All right, so we went through that. Well, in order to solve this problem, they came up with this idea that energy must have to be radiated from these bodies in discrete quanta and not in any old frequency that they wanted. And then the idea came that the electron is not able just to be anywhere in this region of the proton, but there were certain energy states that it could inhabit. And those energy states were quantized. And when a photon was emitted by an atom, it was because the electron jumped from one energy state to the other. So again, what we see as energy leaving the atom is simply a change in energy state. And likewise, if it absorbs a proton, then it might be able to shift to a different energy state. This became the new model of the atom. And so in this model then, it turns out that there is no such thing as the electron being in between these two states. It's not like going from one stair to the other where you can follow a ball or a foot or something going from one step to the other. It's either here or it disappears from there and reappears at some other energy level. So this is beginning to be a rather spooky view of physics. And what Heisenberg's uncertainty principle says is that there's a fuzziness to the reality of this world. And it's because we can't measure anything, we can't measure everything about something accurately at the same time. Actually, you can't measure anything about it accurately. And the more accurately you measure one component, the less accurately you can measure the other. Now, this is the mathematical description of that. Does this have a pointer yet? Yes, it does. This doesn't quite show up, though, does it? But the idea here is that first symbol means the uncertainty in some x component times the uncertainty in the momentum. It always has to be greater than or equal to an extremely small number. Planck's constant is 6.63 times 10 to the minus 34 joules times seconds. Now that's a lot of sort of gobbledygook if you're not used to all these terms. But let's get an idea of how big a joule is. A joule is a unit of energy, and it's about the amount of energy that's used to lift a small apple 1 meter. And in this case, since it's a joule second, it would be in 1 second. Now, to knock it down in size, so we get some of those negative exponents there, 1.6 times 10 to the minus 7th joule is the energy of a flying mosquito. Now, we have about a billion magnitudes smaller to get to 10 to the minus 34. So this is an extremely small number. And so you might think, well, who cares about uncertainties of that magnitude? Well, when you get down to the size of an electron or a proton, then it starts to matter. It doesn't matter for things like you and me or tennis balls or even rocket ships. But it does matter when you're trying to pin down where is the electron in this atom? How close is it to the nucleus? What direction is it going? And the difficulty is, if you measure its direction, you have to measure it with something. You have to send some sort of energy in there and have it bounce off, or a particle or something, so that you can measure where it is. And by the time you've done that, you've wrecked the situation. It's like trying to figure out where a ping pong ball is in the middle of a room by rolling a bowling ball at it. Well, by the time the bowling balls hit the ping pong ball, you don't know where the ping pong ball was. You've wrecked all the information you were looking for. So this is the difficulty, and Heisenberg's uncertainty principle is one of the things we're most certain of. Interestingly enough, it's one of the most tested hypotheses. And it just seems to be true, no matter how peculiar it is. So, these are some of the difficulties that we've faced in our physics. Light has both particle and wave-like properties, and it turns out electrons also have wave-like and particle-like properties. And you can extend that. Everything seems to have wave-like and particle-like properties. It's just that when things get larger than an electron, you don't notice it so much. Although I've heard that they've actually done some experiments with macromolecules now of some size that have still been able to demonstrate the wave nature of those macromolecules. I think they're like buckyball molecules that they've used to do those. And they've been able to get diffraction patterns by shining radiation through crystals and so forth. All right, so what we've had to settle for in our physics is that electrons and protons and neutrons, the basic building blocks of our physical world, our real world, can best be described in terms of probability waves. And that the electron really doesn't exist as a real entity until a conscious observer collapses this probability wave function and makes a measurement of it. So the crucial thing about these two basic new ideas of our physics is that the observer is now mixed into it. In relativity theory, your measurements of space and time are dependent on who's measuring and how fast they're going with respect to the events that they're measuring. And in quantum physics, it depends on a conscious observer to collapse the probability wave function. Other than that, all you're talking about is probabilities. And it could be here, it could be there, and there's some places where it's more likely to be, but you don't really know where it is. So, it seems to me that if we're looking for a new model, that we need to look for a model that somehow incorporates this idea that it's an observed reality and not an actual reality. What religious philosophy best fits a universe that is dependent on observation and is not objectively real without a conscious observer? Answers? Vedantic, yes. Shankara's idea of an apparitional universe. That somehow this universe is not as real as we think it is. And that we can't say Maya is unreal, but it's this peculiar mixture of real and unreal. And so let's start with this idea and see how far we can get with it, and if this would actually predict some of the things that we see. So first of all, we'll read some scriptures from the Upanishads to make sure we're being well grounded here. From the Svetasvatara Upanishad, we have mind and matter, master and servant, both have existed from beginningless time. The Maya which unites them has also existed from beginningless time. When all three, mind, matter, and Maya, are known as one with Brahman, then it is realized that the self, with a capital S, is infinite and has no part in action. Then it is revealed that the self is all. From the Isha Upanishad, it says, by the purified mind alone is the indivisible Brahman to be obtained. From the Vivekachudamani, Brahman is eternal, pure, unchangeable, absolute. Brahman is infinite. The Atman must necessarily be changeless and eternal, since it is the knower of all that is changeable. Brahman alone remains supreme, infinite, changeless, the one without a second. The world of appearance is a mere phantom. There is but one reality. It is changeless, formless, and absolute. How can it be divided? Now notice how many times we saw words like infinite, undivided, changeless, or unchanging. Brahman is said to be indescribable, but we all talk about it anyway. So we have to talk about it in some sort of terms. Well, the safest way to talk about something that's indescribable is to talk about what it isn't. And so that's why the Upanishads and Shankara use these terms. They say it is infinite, which means it's not finite. It's unchanging or changeless, which means it's not changing. And it's undivided, or it's oneness, or it's one without a second. And that means it's not divided. So it's infinite, undivided, and unchanging. We have Brahman and its power Maya to create, and its Brahman is beyond space and time. But when it's seen through the veil of space, time, and causation, through the power of Maya, then you get this manifest universe. So we can say that Brahman is this infinite, undivided, and unchanging reality. Now sometimes we'll use the terms Sat Chit Ananda. Those could be considered the best positive description of Brahman that you can get. That it is absolute existence, absolute consciousness or knowledge, and absolute bliss. Now, of course, the question always comes, why did Brahman bother to create a universe through the power of Maya? Well, if you look at the mythologies not only of India, but of all over the world, this question seems to frequently be answered by saying that the unfathomable oneness wanted to know itself. It was lonely and it wanted to understand, or it wanted to know, or it wanted to play, or it wanted to experience. And so these are the best ways we can answer this basically unanswerable question. But in order to do that, there has to be this basic subject-object split. And that's sort of the initial mistake, you could say. The initial part of this apparition is that Brahman somehow magically divides itself into a subject and an object. And again, the mythologies describe this process as perhaps the cracking of the cosmic egg, and then you get the white and the yolk, or something like that. And the interesting about this is that the subject is singular and the object is plural. So you have a singularity of the subject and a multiplicity of the object. Now, the dream is often used as a good analogy for this, because when you dream, you're one of the characters in the dream, and there are all sorts of other things in your dream. But when you wake up, you realize it all came from you. So you're the oneness, you're like Brahman. And when you dream up a world, you're one of the subjects, and there's a multiplicity of objects in your dream. So that's one of the basic fundamental ideas of our cosmology. All right, now, Shankara would give the famous example of the rope and the snake, which I'm sure you've all heard many, many times, that if you see a rope in dim light, you might mistake it for a snake. Now, some people object to that. They say, well, this is implying that you already know about snakes and ropes and sticks and all sorts of other stuff. You know, so that's how do you get around that? Well, the way you get around it is, what kind of mistake can you make about the infinite, undivided, and unchanging? There's only one thing. If you don't see it as infinite, you have to see it as finite. If you don't see it as undivided, you have to see it as divided. And if you don't see it as unchanging, you have to see it as changing. There isn't any other possibility, and you didn't have to have some previous experience of it. If you don't see it correctly, this is the way you're going to see it. Now, how does this show through in our physics? Well, interestingly enough, let's go through the three gunas first. The three gunas, if you try to find them in the Upanishads, there are almost no references to them. They come up in the later philosophies. And you have to realize that Shankara's treatment and Sankhya's treatment are slightly different. It's sort of taking the same pie and splitting up in different ways. So it gets a little confusing sometimes. But if you read Shankara's carefully, you find that the tamas is the veiling power, and that rajas is the projecting power, and that sattva is the revealing power. And these are the three powers of Maya to project this apparent universe. And so the interesting thing is, sattva, the revealing power, when you manifest a universe by apparition, there has to be something of the reality showing through. So we ask ourselves, what is it in our physics where the reality of the infinite, the undivided and the unchanging, show through? How is it revealed? Well, I think that it's gravity that represents the undividedness. Because if you look out in the universe, we notice that everything wants to fall back together again by gravity. Everything is attracted by everything else by gravity. In fact, every proton knows about every other proton in the universe. Its mass is dependent on it being separated from every other proton in the observable universe. That's how it knows about it, is that its mass would be different if there weren't so many protons out there. So the undividedness shows through as gravity, and that's a plurality problem, and that's the proton. The electron is the infinitude showing through, and the infinitude is not a plurality problem. And this is a little difficult to handle, but I'll try to go through it carefully. You know that if you take two magnets and you take the two like poles, they fight each other like crazy. Similarly, if you take two similarly charged objects, two objects that both have a positive charge, they'll fight each other. If they both have a negative charge, they'll fight each other. So theoretically, you could say that negative charge does not like itself, and it does not want to be confined into a small space. But the electron is a very small thing. So what you can do through the magic of calculus, see, I used to be a math teacher, so that was my major, was mathematics. And in calculus, you can do funny things like this. What you do is you take the charge of one electron and you mathematically think that it's spread out all over infinity. And then you find out how much energy does it take to squeeze that one negative charge against itself. And it doesn't like itself, it doesn't want to be next to itself. So you're squeezing it down. So it takes energy to do that. Okay, you squeeze it down, and how much energy does it take to get it down to the size we think the electron is? Remember, this is our apparition of this universe. It turns out that the energy required, the E required, is equal to the m that we measure for the electron times c squared. There isn't anything else there. An electron is not a little dirty particle with a negative charge. It is negative charge seen small. It is the infinitude of Brahman seen small, and there isn't anything else there. This gives me shivers when I think about it. Brahman is showing through every single electron in this universe, and it's showing through every single proton in this universe. So every single electron is this infinitude seen by us, stupidly, through the power of Maya, as small. But it would love to be infinite. And so the infinity shows through as its mass, as the size of the electron, and the charge on the electron. And there is really only one of them. There isn't any this one or that one. You know, if you take two coins and you flip them, there are three different ways they could come up. They could come up tails, tails, heads, heads, or one of them could be tails, and the other one heads. But that could also be the other way around. It could be heads over here and tails over here. So there are actually 4 distinct ways, and so if you're just looking at how that comes up, it would be 1/4 of the time tails, tails, 1/4 of the time heads, heads, and half the time one of each. If you take electrons, they have a property called spin, which is kind of like a heads and a tails. You can have them spin up or spin down. All right, you take 2 electrons and you measure them. And you see how often does it come spin up, spin up? How often do you get spin up, spin down? And how often do you get spin down, spin down? It is not 1/4, 1/2, 1/4. It's 1/3, 1/3, 1/3. This is not a real universe. There aren't a whole bunch of them. It's only one of them, and it's all just a joke. It's all just the play of the Divine Mother. This is not a real universe. The more I look at this physics, it is so obvious that it is not a real universe. It is just a magic show. And it's a very good magic show. The Divine Mother has to be very clever. And the mythologies also talk about this. Many mythologies around the world will talk about how creation started and it was all pure and perfect, and then it just disappeared. I mean, everybody either went into samadhi, or the 2 opposing forces fought each other and destroyed each other, or something. Different myths do it differently. But it's interesting that there is this notion that creation has to be very carefully done or it doesn't last. This creation has lasted quite a long time, and it's because the Divine Mother is very clever. If you just created protons and electrons that were identically opposite to each other, they would just annihilate each other, and the whole thing would disappear, and it's not going to last very long. But you can see that it's not done that way. The electron is negative and the proton is positive, but the proton also depends on the gravitational separation, and the electron does not. And so they are not actually equivalent, and they do not disappear in a flash of light as you would with an electron and an anti-electron. All right, so we talked about this. The electron has to do with the singular observer or the subject, and the proton is related to the multiplicity. You know, this is the old Adam and Eve myth, you see. In Adam and Eve, they are tricked into eating of the fruit of good and evil. In other words, they now are able to experience duality. They're out of oneness and they're in duality, that's all. It's as simple as that. If you see it if you try to make history out of it, you're lost. You're lost on page 2. They're suddenly marrying people in another town somewhere. Then it makes absolutely no sense. But if you read it as a metaphor for falling out of oneness into duality, it makes perfect sense. All right, how does these things show through us? We're part of the universe, and so the sattva should have some revealing nature in our own being. And in our own being, I think it's our search for love, freedom, and peace. Now again, if you look through the complete works of Swami Vivekananda, and you know they used to sell those CD-ROMs that you could, and you'd have the whole complete works, and you could search anything. I don't know if they still have that, but if they do, be sure to get one. If you search for these words, there are hundreds of entrances of these 3 words. Swami Vivekananda loved to use these 3 words. And if he was in one mood, he would be waxing eloquently about the entire universe is nothing but love. Everything is love. God is love. The essence of religion is love, and so forth. And in another lecture, he'll be talking about freedom. Everything is freedom. Your true nature is freedom. And the universe is always searching for freedom. And the goal is freedom, and so forth. And peace, the underlying peace, the ananda, the bliss. So these are 3 key terms that he used a lot, because I think that our true nature is the infinite, undivided, and unchanging. And because of our delusion in Maya, we are running after it for love, freedom, and peace. Now, if you turn those things into spiritual practices, then you're okay. Because when you finally reach God, when you reach Brahman, these 3 things aren't really 3 things, they're one thing. But in the world, you must have noticed that they fight each other. You could say the world's made up of frustration. You want to be free, and then you're too lonely, or you don't have any security. And if you want to be secure, then you don't have any freedom. All right, so these things, the more of one of these you get, the less of the other two you have. And it just goes around like that. You keep struggling to get all three of them, and it never quite works out. You're always sort of having to pay a little bit of one of the others to get more of one of the others. So it's frustration. Now, let's just take a moment to think about what is a living organism. Well, a living organism is very difficult to define, and it's like so many of our categorizations, there's a very difficult place to divide. You know, the gray spectrum is is very difficult to find a line where you can divide it. You have things like viruses that seem to be alive when they're in a cell and not alive when they're not in a cell, and that sort of thing. But probably the best definition I've seen is that a living organism has the ability to direct a stream of negative entropy upon itself. Now, if you don't know what the word entropy means, it doesn't mean much. So let me tell you what it means. Entropy is the measure of scrambledness or unusefulness of energy, you could say. And so your food has a certain amount of useful energy in it, and when you eat it and then you huff and puff on the oxygen, you metabolize the food and it uses energy. But once you've used it, it's scrambled up and you can't use it again. You have to eat more food. And so organisms have to be able to do that. They have to be able to figure out what in this universe is going to provide them with energy that is clean and useful, meaning that it has negative entropy, is the unfortunate way that's termed, and then be able to utilize that. And this has to be a continuing process. So this is a good way of describing a living organism. So when you're a living organism, you have this difficulty that you have to be able to do this. And it's our ego, which I think is somewhat of a genetic invention, that allows us to do this. If you were in samadhi all the time, you would not be distinguishing between sources of negative entropy or energy and things that were not. And as you've heard in the scriptures, if someone stays in samadhi too long, people have to start force-feeding them because they're not going to eat for themselves. So this is a genetic invention to keep us alive. And you could think of our chakras as sort of being symbolic for these different states. Your root chakra gives you an identity. I am this body and this mind. Your second chakra is, in order to perpetuate the species, I have to reproduce. Your third chakra is, I need this energy. I have to get this energy. I have to digest this food, and that will give me energy. And I need to protect myself against other things in the universe. So if this is me and the universe is out there, I need to take from the universe what I need and stay away from the things that are dangerous. So those are your three basic root chakras that sort of allow you to operate in the physical world. Then you get to the upper three chakras, and these are representative more of the cosmological creation model, you could say. Starting from the top, you're at unitary consciousness beyond any duality. Then in the third eye, that's the I-thou consciousness. That's the original mistake of the subject-object split. And then when you get to the throat center, that's the creation through vibration, which will be our next topic. And then the heart chakra is where there's still an awareness of unity and oneness, even though you see yourself as the subject and there's a plurality of objects out there. So I think it's about time for us to conclude, is it not? So there are a few more things that I may continue with this afternoon as I transition into the second part about vibrational cosmologies. But for now, this will conclude our presentation for this morning. So thank you for your attention.